All right, so let's get right into it. A little while back, the AI developer community was buzzing about this new open-source tool that seemed almost too good to be true. We're talking about a tiny, incredibly fast engine for running large language models. It promised all the power of a major framework, but in a package you could actually read and understand. But you know the story behind it? That's even more interesting than the code itself.
So it all kicked off with headlines just like this one on Reddit. When people saw the name DeepSeek, the major AI company, attached to a new tool called NANO-VLLM, everyone just naturally assumed it was some big official corporate release. The hype was pretty much instant.
Of course, like with any story that just blows up online, the headline rarely tells you everything. And in this case, the real story is, well, it's about ingenuity, it's about community, and really about the true purpose of open source software.
So before we get to the big plot twist, let's take a look at what got everybody so excited in the first place. What exactly did NANO-VLLM claim to be?
Okay, so the initial claims were basically a developer's dream. First, it promised blazing fast performance. Second, it boasted a super clean and readable codebase. And finally, it came with a full suite of advanced optimizations, like a packed toolbox. It really seemed like it had it all.
All right, and this is where it starts to get really interesting. The tool was real, the features were absolutely real, but the assumption about who made it, and more importantly, why they made it, that was completely off.
And here it is. This was the top comment on that Reddit thread, and it just completely reframed the entire conversation. This wasn't some massive corporate initiative. No, it was the passion project of a single, incredibly talented developer who just happened to work at DeepSeek. A labor of love, as one article called it. So this is the key thing to understand, right? The distinction. A corporate product that's built for enterprise-level production, handling tons of users, it's got to be complex. But a personal project like this, it's built for a totally different reason, for learning, for simplicity, and to explore an idea in its purest possible form.
For anybody in the dev community, this comparison just clicks immediately. Andrej Karpathy's NanoGPT is legendary, not because you'd use it to run a business, but because it is a brilliant educational tool for understanding how GPTs actually work from scratch. NANO-VLM is walking in those exact same footsteps.
And this gets us to the whole nano philosophy. These kinds of projects are all about stripping away all the layers of complexity and abstraction to show you the core logic underneath. They're intentionally minimalist so that one person can actually sit down, read through, and understand the entire codebase.
Okay, so if it's just this lightweight educational project, how on earth is it so fast? I mean, how can it possibly compete with a massive production-grade framework?
And this just brilliantly illustrates the point. The entire engine is only about 1,200 lines of clean Python code. That's it. In an age where code bases have tens of thousands, even hundreds of thousands of lines, it's shockingly small. The simplicity is its strength.
So the secret isn't some kind of magic, it's just smart trade-offs. The creator intentionally cut out features that are needed for complex online services, things like dynamic batching and real-time streaming for lots of users. By focusing purely on perfecting single offline inference tasks, the code can be way leaner and way faster.
But don't let its size fool you for a second. This thing is packed with cutting-edge optimization techniques. It's using stuff like prefix caching to remember parts of a conversation, tensor parallelism to split the work across multiple GPUs, and even advanced tools like torch compilation and CUDA graphs to slash latency. This is some serious engineering.
So how does all this shake out in a real-world test? Let's look at the benchmark. And this is the punchline. As you can see in this direct, apples-to-apples offline test, NANO-VLM was actually a little bit faster than the original. Yeah, it delivered over 1,400 tokens per second compared to VLM's 1,360.
Now, context is everything here. This really impressive result was on a very specific setup, a consumer-grade RTX 4070 laptop running a really small 0.6 billion parameter model. So we're not talking about an enterprise server, and that's the whole point. It's optimized for a completely different world.
As you can probably imagine, these results kicked off a huge debate online. What is a tool like this actually for? Is it just a cool experiment, or is it something more?
So one side of the argument was just purely practical. A user on Reddit pointed out that for enterprise use, there's basically no reason to use this over the battle-tested, feature-rich VLLM. And you know what? For that specific use case, they are absolutely right.
But then another commenter immediately captured the perfect counter-argument. These individual projects have a value that goes way beyond production use. They're about learning,
about sharing, and about celebrating ingenuity. They are vital to a healthy open-source ecosystem.
So this slide really clears it all up. Who is NANO-VLLM actually for? Well, it's perfect for researchers who are prototyping new ideas, for students and educators who want a readable guide to inference, and for engineers working on devices with limited resources. It is not for busy online services that need to handle tons of users at once. Its limitations are actually intentional design choices.
And this brings us to the big takeaway here. This isn't just a story about one cool piece of code. It's about why these nano projects are just so incredibly important for the entire tech community.
I mean, think about it. These projects, they democratize knowledge by making these super complex systems understandable. They lower the barrier to entry for new developers trying to get into the field. They create a safe playground for experimentation that can lead to the next huge breakthrough. They really are the seeds from which future innovation grows.
So, the crucial point is this: NANO-VLLM, just like NanoGPT before it, is way more than just an inference engine. It's a teaching tool, it's a conversation starter, and it's a perfect example of how an open, collaborative community pushes itself forward. It's really a testament to the power of learning in public. And that leaves us with a final thought, doesn't it? In a world of ever-increasing complexity, the power to simplify, to teach, and to share, well, that's more valuable than ever. It makes you wonder, what's the next big intimidating system that's just waiting for its nano moment?